In this video, I'll show you how to convert between vertical and horizontal transformations. All functions can undergo vertical and horizontal transformations. Take a look at this generic representation of a function in g of x. We have g of x being equal to the coefficient of a multiplied to the function f, where the input is k times x. A vertical transformation occurs when the coefficient a is modified, while a horizontal transformation occurs when k is modified. Now, if you've studied this before, you've probably recognized that a vertical stretch and a horizontal compression have the same effect on the shape of the graph, while a vertical compression and horizontal stretch also produce that same effect. Now, why is that? Let's take a look at a few questions so we can learn why. In the very first question, we're asked, given the function f of x is equal to 4, that being your a value, your a coefficient, and in brackets we have 2 bracket x plus 2 all raised to the power of 2 plus 5. So we're dealing with a quadratic, and this 2 represents your k value. We're being asked, A, state the transformations. Now, if a is greater than 1 or less than -1, we say that it is a vertical stretch. So we'll start with that by a factor of 4. And what this does is it makes the graph skinnier. So in this case, the parabola would start to look like this. Furthermore, k being greater than 1 means that we have a horizontal compression by a factor of half. So whatever your k value is, you make it 1 over that value, or you take its reciprocal. In addition, this value is plus 2, which suggests that it is a horizontal translation to the left 2 units, and the constant term plus 5 means that it is a vertical translation up 5 units. That covers question A. For question B, convert f of x so that there is no horizontal transformation. So they want us to somehow make this k value as 1 without changing the shape of the graph. To do that, we can use some algebra. We can distribute this power of 2 to the two factors within the brackets, being 2 and x plus 2. And this makes our function look like this. We have 4, and now we have 2 to the power of 2, which makes 4, x plus 2 to the power of 2, and notice that the power of 2, that exponent, is no longer written out here because we've distributed to the two factors, plus 5. As a result, we can now multiply 4 and 4 together. Before, we couldn't do that. We couldn't multiply 4 and 2 together because of that exponent 2. 4 and 4 makes 16, x plus 2 in parentheses to the power of 2 plus 5. As you can see, the function in purple is different looking than what we have here, but is mathematically the same, and they would look the same if you were to graph them. In question C, convert f of x so that there's no vertical transformation. This one's a little more tricky, and the reason why is because you need to know your algebra. What they want us to do is make this 4 into a 1 without compromising the shape of the graph. The way we can do that, since we want to place it within these brackets that's being raised to the power of 2, I can square root 4, and that makes 2. And then I can inject this 2 into the brackets of our function. So if that doesn't make sense to you, let me show you what I mean. So by square rooting this 4, I get 2, and I'll place that 2 within the brackets. So I have 2 times the original 2, x plus 2, brackets, to the power of 2 plus 5. Multiplying 2 and 2 together makes 4, and this is what our function would look like, and it would produce the exact same shape. Now let me explain why this works. If you were to take this exponent 2 and have it distributed to that very first factor, you would get 2 to the power of 2 being 4, and that 4 can be taken out of the brackets and be written as a factor on its own as it was in the original function. Let's apply this technique to question 2. Given the following function, f of x is equal to 3, the square root of x plus 1, state the transformations. So we have an a value, again, being greater than 1, which means that it's a vertical stretch by a factor of 3. And our constant term, being plus 1, means that it is a vertical translation 1 unit up. That covers question A. In question B, convert f of x so that there's no vertical transformation. So somehow we need to write this so that a becomes 1. And Again, this requires a bit of algebra. What I can do is I can take this 3 and raise it to the power of 2, make it 9. Then I can inject this 9 within this radical, within that square root. So I have the square root of 9x plus 1. The reason why this works is because if we were to apply the exponent laws, you can apply the square root to the individual factors. So I can have the square root of 9 and the square root of x plus 1. The square root of 9 makes 3. So you can see that applying the square root to 9 gives you back what we started with. Therefore, here we have a function that no longer has a vertical transformation, but instead has a horizontal transformation, and specifically a horizontal compression by a factor of 1/9. I hope you can see the similarities between vertical stretch and horizontal compression. If you have any further questions, let me know in the comment section or use our website at biology-forums.com. Thanks for watching.